Hi and welcome back. So in the last video, I should say bunch of videos, we were talking about elements that were sort of in this block right here, which we called the D block. And what we're going to do in this video is we're going to start tackling the F block. And if you remember the F block, essentially the F block fits in right here on our periodic table. And it's kind of labeled by the atomic numbers, where we have 57 through 70 go right here, and then 89 through 102, which we have 89 through 102 go in down here in the, what would that be? 5, 6, in the 7th period. So anyway, let's actually get started. I'm going to clear off all of my drawing. And a couple of things that we should really, I guess, talk about before we jump right into the F block is essentially there is, I guess, maybe a little bit of a rule for electron configurations, probably in a first year chemistry course, which that's essentially what we're covering in this playlist is, material that you would see in a first year chemistry course. We're not really going to, you're probably not going to be asked to figure out the electron configuration for an element that is inside the F block. Let me just say this is the F block. Or at least you're probably not going to be asked to figure out the electron configuration for an element inside the F block. I would say if you are asked to figure out the electron configuration for an element inside the F block, I guess first off I should, this is a disclaimer, I'm probably not the most qualified person to teach you how to figure that out. Because I didn't have to do that in my chemistry course, so that's just a disclaimer right there. And along with that, I'm kind of making these videos a little bit out of order, so I think I might do an example of figuring out the electron configuration of an element that's in the F block at some point later on in the playlist. So I guess you should if you. I'm actually probably going to try to find that video and maybe take it out of the playlist. But anyway, the important thing to realize right now is essentially, or essentially what I'm going to tell you is my understanding of how to fill up elements inside of our F block. So and also I should say the big thing that I am going to try to teach you is, so if we say that the F block fills in right here on the periodic table. And essentially what I am going to try to teach you is how to fill up, like if we said that we were trying to figure out the electron configuration for iridium, or if we were trying to figure out the electron configuration for lead down here, we're going to need F orbital electrons, right? We're going to need to put we're going to need these F orbitals to fill up, because you can see lead's got tons of electrons. It's got 82 electrons. We're going to need these orbitals, and we're going to need to at least know a little bit about them. Even if we can't necessarily, even if on a test I can't necessarily tell you exactly what the electron configuration would be for this element, for TB. I don't even know what that is. Or I wouldn't necessarily be able to know exactly what the electron configuration is for neptunium, or at least not without having almost memorized it, because as I said there, I think neptunium is going to be one of our exceptions for what the electron configurations are going to look like for elements in this F block. And again, you're probably not really going to be asked to do that in a first-year chemistry course. What you will be asked to do, definitely, is figure out, electron configuration for mercury. You're going to need to fill in F block electrons. You're at the very least going to have to know the order of orbitals that they fill in, and also how many electrons can go into F orbitals. So anyway, with that, I guess, background information, let's actually get started a little bit on the f orbitals. And to start out, I'm actually going to go down to this chart that I have. So it's the orbitals chart. And now we're going to look at the f orbitals that we have. And you can see that our f orbitals are going to be over here. And we've got a whole bunch crazier shapes, I guess, to start off with. And the important thing to realize, so if we remember our d orbitals were over here, and always remember our rule is that we can fit 2 electrons, so 2 electrons per orbital. So in our d orbitals, we were able to fit how many electrons? We were able to fit 10, right? We were able to fit 10 electrons into our d orbitals. How many electrons are we going to be able to fit into these f orbitals? Well, how many different orbitals do we have? We've got 1, 2, 3, 4, 5, 6, 7. So we've got 7 orbitals. And I'll definitely do in the future, probably towards the end of the playlist again, I'll do a video on why there are 7 orbitals. But for right now, the important thing to realize is that we have 7 orbitals. So how many electrons are we going to be able to fit into 7 orbitals? Well, it's going to be 14, right? 2 electrons per orbital. 2 electrons per orbital. We've got 7 orbitals. So therefore, we're going to be able to fit 14 electrons into our f orbitals. The next thing to realize, or the next important thing to realize, and we'll actually attack this from the standpoint of doing an example. Let's, and actually, you know what, this is kind of it's starting to get a little messy, so I'm going to go ahead and erase my drawing, and I'll go ahead and draw the periods back in. 3, 4, 5, 6, 7. And let's approach this from an example of, let's say we're doing the electron configuration for Mercury. So we know that, let's actually just start off doing electron configuration for Mercury. And so we start at the beginning, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now we're on 3d10, then 4p6. So we now, at this point, have an electron configuration similar to krypton. So we've got 30 electrons here. Or do we? Yeah. We've got, oh no, that's right, krypton is 36. I crossed off with 6. So we've got 36 electrons here so far. So now we're on 5s2. So we've got 5s2, 4, because we're in the fourth, we're going to start filling up our 4d orbital. So we're going to have 4d10. Now with 4d10, we have an electron configuration that's a lot like cadmium, or this is the electron configuration for cadmium. And so now after 4d10, we fill up the 5p orbitals, so 5p6. We've now got an electron configuration like xenon. Now we move on to 6, so I'll move down to the next row. We have 6s2. And now, after 6s2, we're right here at the periodic table. So we're going to start filling in our f orbitals. And we know that we're going to have to completely fill those f orbitals, right? Or at least we're going to have to completely fill the f orbitals that are going to happen right here. So we know, at least, that they're going to be completely full. So we're going to have some, we don't know what the number is yet, we're going to have some orbitals, the f orbitals, they're going to be completely full. We know that when they're completely full, that means they have 14 electrons in those orbitals. And now, just like we backfill one orbital with our d block, so just like, you know, our last entry for titanium is 3d2, and you know, just like we went back one period essentially, in the f block we're going to go back 2 periods. So instead of being 6F14. This is actually going to be 4F14. So that is going to be our completely full 4F orbital subshell. So now we just have to get over to, we need to fill up our 5d orbitals. So the very last thing that we have to do in this orbital configuration is we are going to put in our 5d orbital, or our 5d electrons, and we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So we are going to say 5d10. This is going to be our electron configuration for Mercury. So anyway, hopefully, and this is really going to be the most important thing to understand, is how to make electron configurations for elements that are in the D block and the P block, especially, that also have got f orbital electrons in them. So let's go ahead and let's count up all of these electrons. So we're supposed to have 80 of them. So we've got 2 plus 2 is 6, 2 plus 2 plus 6 is 10, plus 2 plus 2 plus 6 is 20, 30, 40, 48, then we would have 54, so 54, 56, then we're going to have 60, 70, so we've got 70 electrons after we have the 4F14, and then we add 10 more, and that gives us 80, and that's exactly what we're looking for. We can check to see that this all equals 80 electrons. So anyway, hopefully you found this video useful. In the next video, I'll maybe do one more example. Maybe I'll do lead, I guess, in the next video. And then after that, I'll just do a few examples of elements that are in this F block. So anyway, thanks so much for watching, and I'll see you in the next video.